Am I audible? Can one of you confirm?
Yeah, audible.
Thanks, Arpit. Hello everyone. I think we all know why we are here today. Um, Nevertheless, I'm going to introduce you to the agenda of the webinar. Who is it? Who is organizing it? And the speakers for the day. So basically, this machine learning webinar is organized by JAG Educate, edutech startup company which was started in 2017 by NIT Rourkela and XIMB alumnus. Since then, JAG Educate has been trying to implement innovative pedagogy and has tried to give education a new shape and dimension so that people from Odisha or anywhere else can reach their dream institutes or the top places in the world. Um, so starting with the speakers of today, we have Gaurav Patnaik, who is an NIT Rourkela alumnus and XIMB alumnus as well. He has had over 10 years of industry experience. He has worked with Fortune 500 companies like Vedanta and Honda. And in 2017, he decided to start his own startup, which is JAG Educate. We'll then have Mr. Arpit Bhal, who has just completed his master's in data analytics from ISADE, Barcelona. That is one of the top B schools in the world for this program. And currently, he's working with a Berlin-based startup in the same stream as the webinar is about. Then we have Mr. Amrit Patnaik. He is also an XIMB alumnus and has had over 15 years of IT experience and exposure. And currently, he is handling large scale machine learning projects. So, why are we doing this webinar today, and how is this different from all the other machine learning workshops that you have done until now? Here, we are trying to make you understand not just what machine learning is and or what it is capable of doing, but we will get you real life examples that you may have come across in your day to day activities, in your social media or a lot of apps that you're using. So we'll show you the interesting aspect of machine learning and how it can be used for good, or the scope of it, how innovatively you can use it. And along with that, there'll be other interesting things which Gaurav sir and Amrit sir is going to get it for you. I think the session will be started by Mr. Gaurav Patnaik. Sir, I'm handing it over to you.
Thank you, Simran. Now again, the traditional, am I audible? Can you see my screen?
Yes, sir.
All right. So good evening, guys. And see, we got a basic outlay on what the audience is. So most of you are in the early stages of your engineering career. So we just made a few last minute tweaks to the presentation with this point of view that you would have some idea, but probably not much. So we'll try to keep it as simple as possible and still cover something which is a little more complicated as well. So we'll try to keep it balanced for the different types of audience that are here. So the agenda is basically a glimpse into the application part of machine learning. Now the key word here being application. So we will touch upon the theory of it a little bit, but that again we will try to look at it from an application point of view. Again, you are all engineering students, so that's basically applied science. And I think, and I hope you really like what we are going to present today. Now, this is something all of you would have seen or possibly contemplated at some point in your life. Okay, this is AI, this is ML, this is deep learning. So, what is what, or rather, which is which? Let's start with that. Now, artificial intelligence is the superset. Then you have machine learning under it. Then you have deep learning under it, and of course, neural network, which is an integral part of the deep learning, is a subset of it. Now, what do these things actually mean? I mean, these are just terminologies. So when we talk about AI, We can talk about self-driven autonomous vehicles. The key word here being autonomous, not self-driven. And when we talk about machine learning is basically applying algorithms to teach machines to be self-driving. Again, what does that mean? So if you have an autonomous vehicle that can go from one end of your country to the other end of your country without any help from you, that's basically autonomous. But when we talk about a vehicle, let's say that is taking into account, let's say it's working on how Google Maps is rerouting it. Now, how does the Google Map work? It will primarily be based on machine learning because we have uh, told it to tell you, the driver, based on these circumstances, that route would be the shortest or the fastest route available. So take that route. So that basically is the difference between artificial intelligence and machine learning in a very layman's method. It's just for basic understanding to build a platform from where we will grow on. Now, these are the three primary types of machine learning. And again, you probably would have heard of unsupervised learning and supervised learning. Then the third part is reinforcement learning. So we'll come to each of these types of learning in a bit. And again, this is the part where the magic of data analytics comes into play. And again, data analytics in itself is a huge domain. And most of the jobs that you see right now, especially let's say consulting areas, even in engineering, that is primarily based on data analytics. Again, even in data analytics, most of the jobs that we, or most of the work that we hear about, that really uses classification and regression. Whether it is, how the stock markets will perform, how the COVID numbers will move, even to an extent whether India will win the next match or not. This is all based on data analytics. And when it comes to the three types of learning, unsupervised, supervised, and reinforcement learning, they are different, but they are also similar in certain ways. Now we'll just have a look at in which way they are similar, in which way are they different. Now this is supervised learning. You have to teach the baby everything that you want to teach or want the baby to do. You starting with feeding the baby. Because if you go to unsupervised learning, the output could be anything. This is the primary difference between supervised learning and unsupervised learning. The outputs are pretty much closer to what you want in supervised learning, may not be so in unsupervised learning, especially the immediate outputs. And then you have reinforcement learning, wherein let's say, in plain simple words, the algorithm is given a gift if it gives a positive result or if it gets a positive result. So it becomes reinforced in it that, okay, if I do this, then I get a positive result, which means it is a good thing. I should do more of that good thing. It is like how you train a puppy. Even your algorithms that, let's say, beat the grandmaster of Go. Go is the most complicated game that we know of. Way more complicated than chess. So that was again based on reinforced learning. Now, when we come back to unsupervised learning, the thing is, it takes time, but usually the results are much better. It's like you learn on the job. You make mistakes and you learn. That, in a way, is probably the best way to learn anything. And the two things that we saw in terms of analytics, again, they are mainly regression and classification. What are these? So regression is basically playing with continuous data. So I can predict what exactly the temperature would be, let's say tomorrow. And classification really deals with segregated data. So I could say whether it will be hot tomorrow or will it be cold tomorrow. It's like a yes or no answer. But again, coming back to unsupervised learning, because that is something that we will be looking at today in a much focused way. So this is unsupervised learning. You have a set of inputs, which is, let's say, based on the machine's observation, and then it separates the input into different forms of output. Let's say it clusters them. So in this particular case, it took the input and then it is dividing into ducks and not ducks. But it does not know that those three are ducks. It does not know that these two are not ducks. It just knows that that's different. Okay, so that is basically the learning. And in animal kingdom, unsupervised learning is something that we see everywhere. And probably that is fundamental to us, fundamental to our learning. We observe and we learn. We just don't need to be trained all the time. So that, see, understanding the difference between these three is very important, because this is the concept that we are taking to machine learning. Machine learning is not something alien. It is basically based on how humans learn. So what we are trying to do is we are trying to make the machine mimic human actions, thoughts, and behavior, primarily how we think. So, and again, that translates to intelligence. So we are trying to mimic human intelligence in machine, that is artificial intelligence. So again, when we look at deep learning and machine learning, more or less they are similar things. But what happens in deep learning is that we are not really guiding the machine to say, okay, if this is the input, that is the output. Okay. We could probably say, okay, now you take these nodes. This is how we want to classify it, but the machine makes its algorithm on its own. Now that is just to say, very layman terms, what happens inside that black box, how it is forming those algorithms is not known to us. How it is thinking, we don't really know that. But in machine learning, again, deep learning is a subset of machine learning. But in core machine learning, we are basically telling the algorithm that this is what we want. This is how we want to classify. And this again, this part of machine learning is what we see around us the most. Why? Probably because here we can exercise our power to choose. We somehow integrate our biases and choices to make the output probably come out faster, or perhaps to be in the way that we want it to be. So this is again one form of classification. Like we saw in the previous slide, it does not necessarily have to be a yes or no slide which has two options. It can have different options. It can be classified, let's say in this case, into 6 categories. Now, had it been a deep learning algorithm, probably they would have realized, I'm just saying, for example, that no, paper should probably go into an organic matter should probably paper and organic matter should probably go into the green dustbin, because people associate that with these particular garbage with green dustbin. But in machine learning, we have already told the machine, no, paper goes into blue, glass goes into green. So in that sense, they are different. Deep learning thinks on its own. Again, this is another form of classification. But the most important classification, where all the big data, the business, everything, most of the things that we see around us is here, classifying people. We'll just take one example to see what that really means. So let's say this is how the classification is done. Now, let's say you have two categories of people, and one person in M1 category says, hey, can you find me a date? Again, machine learning to the rescue. Tinder uses machine learning algorithm to find this guy a match. Now, this is probably something you would know, but let's see how it really works. So let's say we have 3 people, Tenali, Dhruv, and Diana. And this is the information we have collected about them. Okay. So take 30 seconds, look at the screen, look at all the information that we have collected about them, and probably write it somewhere. Who do you think would be the better match? Tenali, Dhruv, Dhruv, Diana, or Diana, Tenali? As in match, as in, let's say, life partners. Let's see what you get. You can write it in the text box. That would be better. That probably is a prize for whoever guesses it right. So we'll just give you 15 more seconds. Answers, please. Let's see how we go. Quick, 5 more seconds. Okay. So what we really see here is at the core of machine learning. We need data to make decisions. And that is where, the big data and all, everything about data that we hear comes into play. Data, like, and this is something that you have already heard. Data is the new oil, but how to really refine the oil, process the oil to get the valuable products like petrol, diesel, kerosene is what really matters. So again, but how to really get that data? So Arpit will take it over from here.
Yeah, I hope my screen is shared. So, hello everyone, warm welcome. I'll just start off with a brief introduction of me and what I've done on analytics. I did a master's in this field, and post which I have about 1 year of experience in analytics. So, analytics, as we understand it, it's divided into three parts mainly, right? So first is data collection, collecting the right data on which you'll do any kind of analytics. Second is your processing and doing all kinds of algorithms and stuff. And third is your visualization part, or how you make sense of those modeling outcomes to fit in your business or to extract any business value from the entire process, right? So I'm gonna give you a brief on all these three processes, probably not the last one, but the first two, which are the most important aspects. um, we'll go briefly since we don't have time. First, I'll be going into the data collection, right? So one of the most crucial aspects of analytics is that we have the right kind of data, right? Unless we have the right data, it doesn't make sense. No matter how much, how sophisticated a model you have or algorithms you use, it's of no use if you don't have the right data. So I'm gonna go and show you how basically we have data collection methods, right? So from my experience, what I've seen, I've used two major ways of collecting data, right? And the way it's done in the industry, probably the second one. The first one is there's a library called Selenium in Python, which basically goes and scrapes information from the web, much like we do it manually, but it does in an automated fashion, right? The second one is third-party tools. These are basically cloud-based platforms, which essentially have the same concept of collecting information, but it's cloud-based, right? I'm gonna give you two examples. I'm gonna show you how basically we use Selenium and we use the second method of the cloud-based storages, right? Cloud-based collecting ways, right? The image on the left is a project that I did that we are going to go into shortly, and this encompasses scraping as well. But the image on the right is totally based on scraping. The Amazon webpage that you see, it has all kinds of information that we want to extract, right? And that's what I'm currently doing in my current job. So you see a lot of information about the project of the product in the page, like price, if there is a offer going on, the product images, who is the seller, and if it's in stock or not, if it's fulfilled by Amazon, or is the seller is actually shipping the item, all those kinds of details, right? And the way it's done in the industry is it's not just one product, right? We scrape 50, 60,000 products per day, right? So it's a huge volume of data that we're collecting each day. So we need a proper pipeline in which the data is collected and the data is ingested for further processing, right? So unless we have a proper setup, and that's one of the major things going on in the industry right now. Once you have the entire pipeline set, your data comes in an automated way. You do whatever processing on it. You do a visualization tool. You use a visualization tool which basically takes data from your algorithms and whatever processing you have done, and then the business guys will basically see those visualization reports and take decision on it, right? So without further delay, let's see how basically Selenium works, right? So this is one of the projects that I did in one of the internships that I did. So what our objective was, we basically go into Supreme Court's website. It was a legal based project, so we basically go into Supreme Court's website. We scrape judgments, right? And there are particular PDF files for each of the judgments that are there in Supreme Court's database, like you can see on the screen here. Once you select information on what kind of judgments you want, it basically gives you all the PDFs, and you need all those information, right? You need to scrape all those information using Selenium, right? So the URL that you see here, I basically use a script. This is the same exact URL, and this is basically using Selenium library. And the way you saw me go into this page, it does exactly that. I'll fill in the captcha. All this is manual, right? But now we'll see how Selenium does it in an automated way, right? So I'll just run this script. And now whatever you see is totally automated. It opens up the website. It goes to the judgment page. It enters the captcha. It enters electricity in the search box. It enters the date as well, and then clicks on search. Now the PDFs are loaded, the name of the judgments. So when you click one of the judgments, there'll be an option to download the PDF, and the script will automatically do that. Go to each link one by one, as you can see is happening, and it downloads all the PDF, and it will store in my local system. There's a folder called test, which is currently empty, but after a while you'll see that all those PDFs are downloaded and saved here. Now this will take some time. While this runs, let's look at another example, right? So this is also one of the projects that I did. The objective of the project is that we go to each profile, in not each, but the target customers that we want. We can go to anyone's profile. We basically collect all the information from their profile, right, and try to understand their interests based on the posts that they're making, right? So if we go to Dhoni's profile, let's say, you see a lot of pictures on life, let's say in general. There's also a sports related thing. So what the algorithm would basically find out is that this guy, sports is one of the interests of this guy, right? So that was the objective. Now, when we go to this profile, and in the script is built in such a way that when I give a profile name, let's say in this case Mahi7781, it will go to this profile. It will collect all the post information, right? So let's say this post has these many views or these many likes, comments, and what exactly is there in the picture, right? So it uses image processing as well. and it figures out what is there in the images, right? And based on that, it will classify the interests of the user. So let's run that script as well and see how that's working. So I'll just run this. Yeah, you see we have got all the post information. Let's say owner is my7781. Each post has a caption, and these are the captions here. Accessibility caption is given by Instagram. So if Instagram also, so it also has image processing algorithm of its own. And it basically tries to detect objects that are there in the image. In this case, it's not able to do it. But for those profiles which have or Instagram detects information, it will show that this image may contain XYZ, right? There's a separate column for that as well. Of course, you have the likes, comments, the location, the URL of the post, and all those kind of information, right? So we will connect this to something we saw earlier, right? In a brief while, and I'm gonna do that, right? Meanwhile, let's see if this is completed. No, it's still running, so let's wait a little bit more. Now, we've seen that the data collection phase, more or less, we have an idea or intuition behind it, right? This is the way it works, right? Let me also show you the cloud-based storage, the cloud-based scraping method. So this is one of the third-party applications that I'm actually currently using in my job. So the difference between Selenium and this is that Selenium runs on my local system, right? I'm going here and running it on my local system. The script is basically running on my local system. So essentially, when I'm powering off my system, the script stops, right? You're no longer collecting information. But the benefit of using a cloud-based platform is that it will run 24 hours, 7 days a week, right? So you just have to give the script, and no matter, even if you shut down a system or whatever, the script keeps on running even while you're sleeping, right? So after, let's say, 2 or 3 days, or whatever time it takes to scrape the required information, you will have the entire data here saved in CSV, and then you can go and download the information. So that's basically how cloud-based platforms come to the rescue, right? So this is completed. Now we can see that all the petitioner, respondent, the details of the judgments, along with the PDF. Let's see in this folder. Now you can see all the PDFs are downloaded, right? So this is how we use Selenium. It's basically automating the manual efforts, right? Okay. Now that the data collection is done, we will move into the next phase, that is the processing and stuff. You will ask, that's a natural question. What kind of analytics we can do on information we have, right? Now, Gaurav has already given you a brief overview of the kind of analytics that goes on, right? Machine learning, regression, classification. Those algorithms are most commonly used in the industry nowadays, right? But we also have machine learning, deep learning, advanced analytics like NLP, image processing, like voice processing, the recommender systems, all those kind of analytics is also done, right? Just to show you an example, in this particular Instagram project that I did, when you given when the system recognizes image, what it basically sees is this, right? It tries to identify objects that it already knows, right? So we train an algorithm with lots and lots of images, of everyday occurring items. And when you give a new image, the algorithm basically tries to identify the objects that it already knows, and it tries to find them in this new image, right? So potted plant, if it's detecting in this image, it already has lots and lots of images of potted plants which it was trained with, and by seeing this image, it tries to identify if there's a potted plant in this image, and it successfully finds it, right? Similarly with chair, that it has identified in this image. So this was basically used in the Instagram project to understand what are the objects present in the image, right? So this is a classic example of image processing, right? Similarly, we have video processing as well, and you must have seen lots and lots of examples like self-driving cars, right? So instead of analyzing just images, it analyzes frames of images, lots and lots of images, which basically constitute a video, right? So that's one example of image and video processing. What else can we do? We can do voice processing, let's say. Alexa is a classic example of that. We can do recommender systems, right? I'm gonna come to it a little bit later. But first, I'm gonna connect what we saw in the Instagram example to something that was asked to you a little bit earlier, right? Now, Tenali and Diana, which most of you said, let's see the common aspects of it. YouTube channel, right? Dancing, styling. Now, Casanova, eat, sleep, train, repeat. Those actually point to a slightly younger age group, right? But if you see Dhruv, it says retired, it says kids, memories. So probably it's going to be a guy which is slightly older, right? And that gives an indication that probably Tenali and Diana would probably a better match, right? Now, the question that was asked to you about Tinder, many of you would ask, how we basically select the people who we match with, right? But you select people when you see them in the app, right? And the algorithm behind Tinder actually intelligently selects the people that it wants to show you, right? You must have often observed that when two guys are using Tinder in the same location, most of the times they see different girls, right? And that's not a coincidence of any kind. That's actually deliberately done by Tinder. It uses image processing. It reads your images. It tries to detect your face and tries to match you or your profile as a whole with people who it thinks that might be a better match, or who you are more likely to swipe right? So now that it's Tinder also has interests, like you can post your interests, like I like sports, I like music, I like whatever, XYZ, right? And so it has now become easy for Tinder to basically match profiles, or to show you relevant profiles, right? Now let's see these three profiles that you see here. These are not actually fictional characters. These are three very real people, and yeah, these are the three people, right? Now, as you guessed, Tenali and Diana, of course, are a better match than Diana and Dhruv, or let's say Disha and Dhoni, right? So in this case, the better match would be Tiger and Disha, right? So this is what basically goes on behind the scenes in Tinder that probably you wouldn't know otherwise, right? Now, recommended systems, as I told earlier. Now, of course, NLP is also there, but I'm going to leave it for Amrit, who is going to be discuss it in a bit more detail. So I'm going to give you a brief or a layman explanation of how recommended systems work. Now, you must have seen YouTube videos, right? You spend hours and hours without realizing, right? So you keep on clicking on videos next after next, and then that's just a classic example of employing a really good recommender system that keeps you hooked to the system, right? Same goes with Netflix, same goes with Spotify, and a lot of other companies, right? Now, when we try to have a layman understanding of how these work, basically what happens is, let's say there's a user A, let's say there's a user B, right? And let's take the example of Spotify, right? A listens to X and Y genre, while B listens to X and Z genre, right? So X is the common genre that both of these people listen to. So what a recommender system will do is think that, okay, X is being listened by both of these guys, so maybe I can propose the other genre to each of them, right? So A is already listening to X and Y. Let's propose Z to A, right? And vice versa. To B will propose Y, right? So that's an example of user-based collaborative approach of recommender system, right? So it tries to find similarities between items and then recommend it to the users, right? Now the opposite can also be done. Let's say there are similar users, right? So it will try to recommend stuff that both of those people here listen to, right? There are also similar items or genres in this case. Let's say you listen to folk pop, right? So indie would probably a better match to folk pop, right? So if you are listening to folk pop, it also will start recommending you indie, right? So that's basically how recommender systems work. It basically tries to find similar items or similar users, right? And the difference between a good recommender system and a bad recommender system is essentially how you're finding that similarity, right? Now, behind the scenes, it's all stats, it's all maths, right? So, the better formula you are able to employ, or the better similarity you are able to establish, the better your recommender system is going to be, right? Now, of course, there are other parameters as well, the number of users, the number of items you have on the platform, all of them come into play. But essentially, it's how you calculate the similarity, right? So that's basically the intuition behind how recommender systems work. Okay, now that we have a good understanding of recommender systems and normal ML algorithms, I'm just going to take 5 minutes to give you intuition behind how deep learning works, right? And I'm going to give you a live demo of that. So if you go to Google and just type in TensorFlow Playground, go to the first link. Now, as said by Gaurav, right? We are trying to mimic human intelligence, right? What better way to do it than mimic the human brain, right? So, deep learning is essentially that, or neural network is essentially that. It tries to mimic the structure of your brain, right? Like we have neurons in our brain, and one after another neuron connected to each other. This is exactly the same architecture, right? There are neurons and there are layers, right? Each new layer is connected to the next layer. Information is being passed from the input, like these are the inputs we have. It goes through a few neurons and layers, and we have the final output, right? So let's actually get now what goes on inside each of these neurons and inside each of these layers. It's a black box, we never know, right? All we can do is get an intuition behind how many layers we should have or how many neurons we should have in each layer, right? So let's take an example. Let's take this one. Let's have two neurons in this layer, and there are two layers, after which we are basically having our output, right? And the objective in this is basically to classify or to separate the blue dots from the yellow dots, right? So let's click on play, and the algorithm will basically try to classify them or separate them, which it's not being able to do. But if you increase the number of neurons or the number of layers, then we see that it's a bit slow. We see that it's taking time, right? But it's eventually able to do it, right? Not perfectly, but it's able to somehow separate. Okay, now we see that it has separated the blue dots from the yellow dots, right? So, but it took a little bit of time to do that. But if you increase the number of neurons and the number of layers, it will be able to do it much faster, right? And there are different data sets in this which you can play with, right? Now we see that it's able to do it. Let's see another example. Let's see this one, right? Let's have 2 and 2 neurons in each of these layers. And we'll see if it's able to do it. Now the point of doing it is just to get an intuition of whether it's beneficial to have one more layer or one more neuron in the same layer, right? So and you only kind of get to know it. There's no particular rule that increasing a number of layer, increasing a layer or increasing the number of neurons is going to do this. It will keep on varying based on the input and output you have, right? So the way you can get better at this is actually by doing, right? So that's why it's really crucial that you work in this field. Like the more experience you have in this field of employing neural networks, a better intuition or better understanding you will have behind what goes on or what will work, right? So that's basically the point of this. Of course, you can go and play around with this, but since we have a time limitation, I'm not gonna spare more time for this. All right, so that ends my part. I hope you've got a good understanding of what encompasses analytics, like from a very layman's perspective. And of course, you can go. It's a huge field, right? Analytics is a separate domain, just like marketing, just like finance, and within that, you have a lot of things. Right? Like we've seen, we have a lot of things inside analytics, and it's very difficult to become an expert in all of these fields, right? So you can just choose one of these. Like let's say the three major things that I told at the beginning, right? Data collection, data processing and algorithm, whatever we have, visualization, right? These are the three main or the three broad areas that we have in industries as well, in companies as well. So you could, in big companies, if you're joining your analytics team, you'll not be working on the entire process, right? You'll be working on any, like one of these three major portions, right? Either you'll be on the data engineering side, which basically deals with collecting and cleaning data. Either will be on the data scientist side, which basically is employing models and doing all the analytics kind of work. or you will be on the business intelligence side, which is basically the visualization side, right? So we use Tableau, we use Quick View, Power BI, all those kind of tools are basically used for visualizing whatever models you have employed or whatever outcome you have generated, right? So that the business guys who don't understand analytics can see the report, can see the charts, and take a decision, right? That's basically the three broad areas that you can go into, right? Now, of course, in startups, you get exposure to all these three areas, and that's why I personally prefer that anyone trying to get a hands-on on analytics, it's probably better to join a startup where you'll get exposure to all of these three areas and a good learning experience to start with, right? Okay, so that ends my part, and I'll hand it over to Gaurav, who will basically take it forward, right? Thank you.
Thank you, Arpit. So basically, we'll try to sum it up once before we go to NLP. Now, you can see my screen, right? So what do you see here? Just have that thought in your mind. If you want to write it up, that's also all right. So you see something here, right? This is a brush. So that's no rocket science. Now, let's say your algorithm has understood this is a brush, and then let's say you put in a command, a query that, all right, I need a brush. So basically, you understand that now your machine, which has learned a few things, will now get you a brush. So let's say it's Alexa, but let's say it gets you this brush, but you wanted that brush. Now, so the next step you take, all right, let me give it a few more commands so that it understands what is it that I really need. So let's say, it understands that this is something that is used probably 100% of the times in the morning. 20% of the people use it at night, and then 1 to 2 times daily usage. Most of the people use it one time, maybe some people use it 2 times. There would be people who use it more than that, but that is something we are taking out of the equation. Let's say we use a Pareto model. What is it? You have coded it, and then you send the query again, and you get this. But is this what you wanted? So you understand, how few, I mean, how similar and how dissimilar they are at the same time. Now, this is where the magic of machine learning, where the magic of analytics comes into play. It's not just about coding; it's about understanding a lot of other things. So then, now that we have understood this, now what will be your query for this? The brush that we saw the first time. Let's say you wrote something, whatever you wrote, and you need this, and you've probably made the best um, code that anyone could. But then, what is this? What is this? What is this? For us, these are all brushes, isn't it? This is basically what men think. But an AI, with probably the help of a female coder, would know that these are not brushes. So you see how subtle the difference could be. Even if you take the first brush that we thought was a brush, it's probably called powder because of its usage. Somehow I don't know that, and it's very easy that it will actually run that query. It will get you talcum powder. I don't know. I'm just saying that. So there are so many subtle differences. So it's not just about the coding. I need that domain understanding to understand what is what. Only then can I write a proper code. So it's not just about coding. Coding comes later. First, I need to understand the problem. To understand the problem, I need domain understanding. And then I can go for a solution. And a part of solution finding is, let's say, knowing how to code. And of course, this is where the AI will, come to our rescue. Now, this is again something you would have seen, like millions and millions of transactions happening every day, everywhere, whether it's Amazon platform, Flipkart's platform. Lots of customer queries are going into service agencies. It's Indigo, and this is one of the more popular service query that came up. So where Roshan Agarwal said, "Thank you for sending my baggage to Hyderabad while I was flying to Calcutta." Now, see, you would be getting so many, hundreds of thousands of messages, every day. So it's virtually impossible for people to respond to that. So you will have chatbots replying to these queries. But what happened in this particular case is it picked up the keywords, it picked up the words probably like thank you for flying me to XYZ, brilliant service. And the algorithm thought, the machine thought, okay, I'm getting a compliment. And so it replied, glad to hear that. So you see how that, how a little bit of understanding of certain things, in this case, sarcasm, would go a long way in making that machine a lot more intelligent, which is what Google's Duplex is doing right now. We will go a little bit deeper into it with NLP as Amrit explains, how it really happens, how it understands texts and not just numbers, how it understands sentences, how it understands language. Amrit, can you take it over from here?
Yes. Thank you, Gaurav. Uh, Guys, let me know once you're able to see my screen. Can I get a yes?
Yeah, we can see it.
Okay, perfect. Uh, so yeah, I mean, just an offshoot of what Gaurav and Arpit covered, right? So as Arpit mentioned, right, machine learning, deep learning, then you have reinforcement learning, and on top of that, you have computer vision, you have NLP. So there are a lot many things in this particular area. Now, if we were to just deep dive and focus on NLP, right? So as Gaurav showed you an example, right? Classic example of a person tweeting or, you know, like a sarcastic message and Indigo getting it perfectly wrong, right? So that was a classic case of sentiment misclassification. The sarcasm straight away went out of the window just because it had a thank you. They said, okay, wow, this is actually a good comment for us. That's where a good NLP system differentiates from a very moderate or a average NLP system, right? So what exactly is NLP, right? So I know like we have a paucity of time, but we'll try to get into a bit of what NLP field is all about, what are the different evolutions which have happened over a period of time, and also take a look at one of the examples as a use case. So just to summarize in a nutshell, right? NLP is basically your natural language processing. So it's like a three-way communication or a three-way subfield of AI, computer science, and linguistics. Essentially, what we're trying to do here is computers trying to understand what human beings are trying to speak and trying to make a sense out of it. Okay. So as you can see, what it does is it facilitates your human computer interaction. Now, NLP as it is has got lot many downstream use cases. We have tried to show a few of them over here. So say for instance, one of them could be text categorization. If I get a particular document, I want to figure out what this document pertains to. What is the relevance? I mean, what is the topic it is actually referring to? So that's like a document or a text categorization. Second example would be sentiment classification. As we saw in the example which Gaurav showed, if I write a certain text or a certain document comprising of text, how can I gauge whether the sentiment that is expressed over there is it positive, is it negative, is it mixed? And mind you, these are the kind of feedbacks which companies take into account when they try to ascertain whether the product is doing well or it's not doing well. It's kind of a user feedback process. Right? Next is the machine language translation. This is probably the oldest example application of NLP. It all started with machine language translation. As you would have seen, right? I think the one of the earliest examples of machine language translation would be when you get to see people speaking at UN conventions, right? You have someone from India speaking in Hindi, and at the same time, you have somebody from Russia speaking in the Russian language. So it's all about trying to bring everyone on a common platform. Then we have something called as text summarization. Now, this is something which has come off late, in leaps and bounds. If I were to give an example, think of a use case or a scenario. I mean, just think of the example which Arpit was showing, right? What Arpit did was he tried to scrape through the documents or the case materials from the Supreme Court website. Okay. Now, the way the lawyers or the legal profession works is, say, for instance, I have a case related to electricity theft. Now, the way lawyers work is they parse through all the cases related to electricity theft. It could be pertaining to say Reliance. Reliance Power has electricity theft, which is under litigation, and it wants to refer to all similar kind of cases. Imagine the lawyers manually surfing through each of these judgments, trying to make sense of what could be the key point or the key driver that could, tilt the judgment in our favor. Replace that, hundreds and hundreds of hours of manual parsing and trying to take a summary with an automated text summarization. That is where NLP comes into picture and makes the life far, far easier. Now, just diving under a hood a bit, like how does exactly a processing happen in NLP? So what happens is that you get a corpus of text, right? And then you feed it into a machine, which in our case is a computer. So does a computer understand a raw text which I'm feeding it in? Say, for instance, the feedback or the tweet which Gaurav showed. Does a machine understand that in its raw format? The answer is a plain no. A machine is simply incapable of processing strings or plain text. The best way to facilitate a machine understand what a language is trying to say is to convert the text into numbers, or as we say, numerical representations, which in other words is called word embeddings. So what we do over here is you take a text, you convert each word into a numerical representation in an n-dimensional space. Okay? So what we're trying to say here is, say there is a sentence called "I love football." Okay? So what this particular sentence will be represented in an n-dimensional space is like every word would have its unique representation in that space. So when a machine encounters this particular sentence, based on the embeddings, it gets to understand, okay, probably this is the vector which pertains to football. This is the vector which pertains to love. Okay. So that's like basically this is the underlying theme or the underlying concept on which the NLP works. Now, why to even go or why to even bother about trying to understand a numerical representation? See, as human beings, the idea is that suppose when two people are talking, right? And suppose I say a sentence, the weather is really pleasant today. And another person speaks the word, the weather is really delightful today. Now, for the machine to understand that delightful and pleasant basically are trying to mean the same thing, that's where the semantic similarity or the conceptual or the contextual similarity kicks in. So that is what NLP field has been trying to do. I mean, just think of an example. You go into a Google website, right? You type uh, you type something. Say, for instance, what is Liverpool's next football match? Okay, the way the field has evolved is initially when Google search used to work is based on a keyword. So it takes into account Liverpool, it takes into account next football match, and it tries to surf through all the websites and it gives you the results. Today, this particular phrase could be actually rephrased in another manner. I could ask a similar meaning question in a different manner. So that's where the semantic similarity or the contextual similarity comes into picture. Now, we'll take a look at a few evolution steps which have happened in the field of NLP. We'll quickly run through these because we don't have much time. So the way it happened is it actually started with something called as a one-hot encoding. So what one-hot encoding means? Say for instance, uh, there is a sentence called numbers are word converted embeddings. Okay. So what I'm trying to do here is I prepare a dictionary of unique words. Okay. Just to give an example, suppose this is a sentence. Word embeddings are converted into numbers. Okay. Now, say for instance, I want to enable the machine to process this text. The first step which I do is I prepare a dictionary or a corpus of all the unique words in the sentence, right? So that percolates down to numbers are word converted embeddings. Now the next step is I assign a unique identifier to each of these words. Okay. So the way I represent this is, if I could go to the next slide, you see over here, there is a word called numbers, right? So the one hot encoded representation of the word numbers would be like something like this. So what we have over here is all the other positions are filled with a value 0, but the last position, which in this case is the position 6, which we assigned the ID 6 to the number word, right? That is filled with a number called as 1. Vis-a-vis, if you convert or if you compare it with a word called converted, if you have a look over here, converted was assigned a position ID of 4. As you can see, there is a way I can clearly demarcate between numbers and words. So this was a very rudimentary or a very elementary way of trying to differentiate between words. So what came next? So the next was we try to understand or judge a document based on the frequency of occurrence of words. So you had two mechanisms or approaches over here. One was called the count vector method, and the second was called a TF-IDF vector. So just to give an example, how count vector works. Okay, suppose you have a document one which has a sentence. It is a beautiful day in a beautiful city. And second, you have a document two which has a sentence. Prague is a beautiful city. Again, taking a cue from the one hot encoding approach, we build a dictionary of unique words, right? To see over here, it beautiful day city Prague. Bear in mind, I have omitted all the commonly occurring words, is, the. So these are like, I don't need these as part of my processing. Okay? Now, if I were to encapsulate this in a document vector matrix, this is how it looks like, right? Document one, it shows the occurrence of each of these words. Document two shows the occurrence of each of these words. Now, this was like a next step or a next evolution in the NLP field. The major disadvantage of this particular approach was, we just took a very simple example, right? Document one has one sentence and document two also has one sentence. But in real life, it doesn't work like that. Your one document could have hundreds or thousands of sentences. Imagine building a dictionary of all the unique words and trying to, mark the occurrences. It would result in a very sparse matrix. When we say sparse matrix, lot of zeros and very few ones or very few non-zeros. This is an absolute nightmare as far as computation is concerned. So what they did was they moved into another thing which was called TF-IDF, which is called a term frequency inverse document frequency mechanism. The whole rationale behind this TF-IDF mechanism is you have something called as very common words like the, is, right? These are like words which almost always appear across all the documents. And then there are certain words which are restricted to certain documents, a limited set of documents. So our idea is that we give higher weightage to these limited occurring words and lower weightage to the most commonly occurring words. So just to give an example, right? Suppose you have something called as a document one, and these are the terms which have appeared across document one, right? NLP is a challenging topic. And this count column specifies the number of times each of these terms has occurred. Now, if I were to calculate the term frequency of NLP in document one, it's basically the number of times NLP has occurred by the occurrence of all the words in the document. So it gives me a score of 0.44. Right? Now, if I were to calculate the term frequency of, say, the word in document one, so that's like less compared to NLP, right? So what it tells me is, as far as document 1 is concerned, NLP is definitely the more pertinent word compared to a. Okay. Imagine another document 2, and these are the words, right? And as you can see in the document 2, football is a more relevant word because it appears more number of times compared to the word a. Okay. Now, taking into consideration what we discussed, we only give a higher weightage to a word which occurs limited number of times. So there is something called as inverse document frequency, right? So if you have a look over here, I have a formula called log n by n. So where capital N is the total number of documents in the corpus and small n is the number of documents in the corpus in which the particular term T occurs. Okay. So going back to our example, if I were to calculate a inverse document frequency of the word NLP, log 2 by 1, right? Because 2 is the total number of documents and 1 because NLP only occurred in document 1, correct? So it gives me a score of IDF for NLP as 0.301. Whereas the IDF for A, which actually occurred across both the documents, is 0, right? So if I were to compute a TF-IDF score, which is like a term frequency into IDF of NLP, I can clearly see that the word, as far as document 1 is concerned, the NLP is assigned a higher score compared to the word A. And A is penalized because it has actually occurred like in both the documents. So yeah, I mean, what I'm trying to say over here is, so these are like some of the mechanisms based on which the NLP world works on, right? You had something called as one hot encoding, which then we moved to count vector, then we moved to TF-IDF vector. Then the world actually thought of, but these are actually not capturing any semantics or context of the word. How do we actually capture a meaning of a word? Like beautiful, pleasant, delightful. These are all like similar meaning words, right? So for that, the NLP world again encountered something called as word to vec model. This was actually a model which was built by someone called Thomas Mitloff at Google. Yeah, I mean, we are not going to get into the details of this, but I'm just trying to give you a flavor how the NLP world has evolved. Okay. Uh, we'll come to the last three approaches in a bit, but before that, I just wanted to show you an example of like one of the use cases. If I could share, so this is one of the examples of the text summarization that we talked about. Okay. Now, as a reference, we have taken this article, very relevant article because this happened yesterday, right? Sensex declines more than 1900 points. Now, if you have a look at this article over here, right, it talks about why this happened because of the rising US bond yields. And it also talks about weak global cues, what exactly lies ahead as far as the GDP data is concerned, right? And also COVID-19 being one of the attributes which resulted in that. Now, if we were to go back to our slide, this total article, the total word count is 889 words. Okay. Now, if I were to run a summarizer on this, bear with me. I'm running it in Google Colab. So what we're trying to do over here is we are trying to build a summarizer of this particular article. Okay. And the model which I have used over here is BERT Summarizer. We'll talk a bit about that towards the end. And I have used something called as the Transformers model. So BERT is an offshoot of the Transformers model. These are like the latest state of the art models. Okay. Yeah. So if you have a look, this is the body of the entire article. If I could show you, this is like I have captured the entire article's context in this Word document. If I go back to the notebook, this is my entire body. And then I run a summarizer. So this is like a generic summarizer which I have used over here. Now this is what the summary has come up. Since it is not very legible, I'll just show you what it actually generated as far as the summary is concerned. Just have a look over here. Indian equities witnessed a sharp sell-off on February 26, which dragged the benchmark. Okay. Then it talks about COVID-19, which was definitely one of the things. Also talks about the rising bond yields in the US. Right. Now, how much this summary comprised of as far as the word count is concerned? 248, even less than the one third. Right. So as you can see, this text summarizer makes your life a lot easier. Be it your legal profession, be it your equity analyst who works in the financial or banking domain, right? They have to come up with this quarterly report of industry analysis. So they go through multiple documents. They go through income statements, bank statements, and then they come up with a summary. Imagine how much it would make their life easier, right? So how did it actually work? So if I were to like break it down, a text summarization works in the following ways. We feed the NLP model the articles which are to be summarized. Now, once we feed them the articles which primarily comprise of text, the texts are converted into the numerical representations or the vectors, which is called text embedding over here. Right?
Brett,
Then
can you
what
go
we
to
do
full
is,
screen, please?
yeah, sure. Yeah. Is it legible now, Gaurav?
Right. Yes.
Okay. Yeah. So once I have the articles text embedded in the forms of numerical vectors, then what I do is I will score each of these sentences. Right? Imagine in our case, the financial article which we had a look at, it had like a lot many sentences. So what the model does is it scores each of these sentences. When I say score, the scoring is done based on how relevant each of the sentences is. And then based on the ratio or the number of sentences I want to pick as my summary, I pick the top key most important sentences. Now, the thing to note over here is it's not simply randomly picking out the sentences as it is. While it takes into account the importance of each sentence, it also tries to ensure that there is a bit of coherence, right? I cannot like abruptly, stop at one sentence and then start off at another sentence. When it's trying to build a summary, there is a bit of coherence also. So the whole summary that I get out of this is meaningful as well as it has made my life easier because it has reduced the number of words that I need to take into account. Now, going back to the evolution slide that we talked about, and this is something like, I mean, this is like each is ocean in itself, right? If you talk about sequence to sequence models, so these were like the next evolutionary step after the word to vec models. These had something called as RNNs and LSTMs. Now, RNNs and LSTMs are again neural network based models, but these deal with sequence to sequence or temporal or time based features. Okay. Then came the next big thing, which is actually you can say it's like a game changer in the NLP field called as attention mechanism. And based on that, you had something called as transformer models. So the whole idea behind these attention and transformer models is it's kind of tries to replicate the way humans interact, right? Whenever you are given a lot of information, right? And just you are trying to make sense out of that, there is a lot of noise and then there is some signal within that. So it all boils down to how much attention you are giving to the noise and how much attention you are giving to the real important information, which is signal. So this whole model is based on that approach. And the one model which we used for summarizer was a BUT model, which I showed you over there. It's actually a transform based model. And you must have, I mean, in the news, you must have read like GPT-3. I mean, Microsoft came up with something called as GPT-3, which they claim has, it's like a zero shot learner. I mean, you feed it anything, it can give you results. While all of it is not true, there is some bit of fine tuning which is needed. But these like models are getting bigger and bigger, and they're trying to encapsulate all the language information that they can. And then based on that, can apply these to any of the downstream tasks that we saw earlier. Yeah. So that's like a bit of flavor as far as what NLP field is and where it is actually heading to. Probably, yeah, we'll look into detail in like in subsequent sessions or subsequent. Yeah. Over to you, Gaurav.
All right. All right. So basically, to sum it all up, this is how the learning mechanism happens. So this is machine learning. Uh, I'll just try to compare it with human learning. So I'm just using simple terms to get an understanding of how it works. So with machines, there is this natural language processing through which it will learn. So let's say one of the language that we use is Python. So once we understand Python, does it enable us to really predict the stock market? What do you think? So let's take this example. Now, how do humans learn?
Folks, just bear with us. I think Gaurav is having some connectivity issue. I think he'll be rejoining in a bit.
Yeah, yeah. Gaurav is running into problem. He's just gonna come back in a minute or two.
Yeah, please bear with us for a minute.
Yeah, so I think essentially what Gaurav was trying to say is that if let's say we are understanding Python, it doesn't necessarily mean that we'll be able to apply it wherever we want, right? We need that functional knowledge as well. Like let's say stock market, for example, right? Unless you know how exactly things work in the stock market, you cannot employ analytics, just analytics, as you know it in the finance domain or to predict whatever goes on in the stock market, right? So you will need that functional knowledge to so that analytics basically helps you do that stuff, right? So that's what Gaurav was hinting at towards the end. I think with that we can wrap up. We can take a few questions. I see a few questions in the chat. Let's take all those questions and then we can wrap up. Okay, the first question I see is how can we know about a customer from his or her post? I think I answered that while I was speaking. So we basically employ image processing to basically read what objects are present in the image. And based on that image, we use an NLP engine again, which classifies that, okay, this user, if these words are found, or these objects are found in the image, then we can classify that this user into a particular interest category. Um, how can we know who are the targeted customers? So this will take a bit of time, so we didn't have time to discuss all of this. Essentially, we use hashtags in I mean, all Instagram, all social media platforms have this. We basically employ hashtags which help us find relevant users in a platform, right? So, let's say a bank is trying to find its customers. Um, so, let's say we search for hashtags like hashtag loans, hashtag mortgages, relevant hashtags, which will help us find out who are the users that are using those hashtags, right? So, uh, this can be one approach of doing it. I think the rest of the questions can be answered. I mean, Amrit and Gaurav will be a bit more qualified to answer those questions about the job market and what opportunities you have in the analytics domain and stuff. So I'll just leave Amrit to answer that.
Yeah, but I think there was a question related to how is the job market looking for the AI ML space, right? Yeah, I think the opportunities are immense. I mean, just to give you an example, we have barely scratched the surface, okay, as far as AI ML is concerned. I mean, even if you have a look at the recommendation system which Arpit was showing you, right? I mean, just think of an example, right? Right now, the vision, the language, the voice, everything works in silo. But as human beings, we don't work like that. You go to a restaurant, you suppose you want to order a cuisine, right? What are the things you take into account? You take into account how the cuisine looks like. You check the Zomato feedback. What is the feedback of that cuisine, right? You take the word of mouth. So, I mean, just think of it like we have like barely scratched the surface, and the opportunities are immense. So, anyone looking for like or having some reservation, what are the job opportunities? I mean, we are just getting started, folks. So, I think Gaurav can shed more light on that.
Yeah, sorry guys, I was running a code, and that is the problem with running codes on your laptop. Sometimes it consumes a lot of energy, sometimes it crashes, and that's one advantage of running it on cloud, which Arpit was talking about. So I was not doing that. So sorry about that. Um, but see again, if I just have to pick it up from what Amrit was just saying. See, job opportunities are enormous. Job opportunities to, I mean, even when I was a kid, I actually understood this lot later. I was probably in class 8 or 9. So we had a teacher, and one of the students asked him, "Sir, even back then, okay, so that was long back. So one of the students said, "Sir, jobs the time, as in, there are no jobs in the market. So what are we really studying for?" So what he said was, his answer was, jobs are there in the market. Jobs are plenty. It is just that you are not eligible for that job. So I didn't really understand what that meant until probably very recently, maybe 2.5 years back, which is always true. Jobs are there. Lots and lots of jobs are there. Even if you take, let's say, management jobs, for example, the really, really high paying jobs, the let's say 15 lakhs to 18 lakhs a year jobs. I'm not even talking about the 25 lakhs. So you'd see, you'd feel that okay, there are not really a lot of jobs like that. But every year in India, at least 50 to 60,000 jobs at management level comes up like that, which have, let's say, 15 to 18 lakh or more annual pay per year. And then when you see all the top, let's say take the top IIMs, you take all the IIMs, not even the top IIMs, take all the IIMs, and you take the top 20 non-IIMs. Even if you add all those seats, that does not reach 40, 50,000. So you see, there is a gap. There is a very short supply of, uh, you to put it plainly, eligible talent, which is true and ever so more true currently in this, let's say, IT space. Why I'm saying IT space, it's not really IT space, but when we talk about machine learning, when we talk about analytics, we are basically talking about technology, and most people understand it with respect to the IT space. But in reality, it is a space on its own. The really, really good jobs, they are probably in the startup sector. There are lots and lots of, for example, Arpit is also working with a German-based startup. Now, I think his colleagues are probably making one third of what he's making right now. So you see, it's all about how you skill yourself. See, you take Fortune 50 companies, more than half of them are not even looking at your degrees. Even a company like Ernst& Young, it's a financial consultant, one of the big fours. Even Ernst& Young, which deals in the financial sector, does not require you to have a degree. You appear its own test, pass it, then you are through. So what is the industry really moving to? It is moving to skills. And do not misunderstand skills as certificates. Industry does not bother about your certificates. These high paying jobs that you think of, they don't really bother about your certificates. They bother about what do you know. So to put it in plain simple English, what I was telling back then, see, if you know English, which you know, of course, does it make you a poet? Can you become a poet? If you know English, does it make you a nuclear physicist? Let's say you are a nuclear physicist who knows physics. Are you also same and similarly good at, let's say, literature? No. See, English is just at the bottom. So coding like that is just at the bottom. It is a tool. It is a means to an end. You need to have that functional understanding. You have to pick and choose your domain. Whether you want to go to finance, fintech, whether you want to go into marketing, martech, data analytics is a science and it's arts. It's a mix of both. It's like poetry in action. Okay, poetry in motion rather. So you will have to understand that certificates, coding, and all that is all good. Okay, it makes your CV look a little better, but that will take you to what? Maybe a job at TCS, a job at Infosys, which pays you 3.5 lakhs. If you want to go at let's say at an engineering level, let's say 7 lakh, 8 lakh, 10 lakh, then you will have to be good at something. And that is not really coding. Coding is just a part of it. If it were just coding, then, see, I'm also from NIT Rourkela, but it would be very difficult for me to, let's say, match up with young people from IITs, and there are so many IITs. So I have to carve my own niche in an area where I can find interest and strength in. That is more important. And again, this is what that is something else we do. We are also one of the, you could say, in terms of result, we are probably the number one in terms of MBA results. Not just MBA, but there are other things that we do. Every year we are able to help people get into the top 10 universities in the world. Just recently, one of our girls, she made it to INSEAD. INSEAD is the number one MBA program in the world. It has been ranked above Harvard, Stanford, and Booth at least 3 times in the last 5 years. Now, how do you get to those positions? So it does not happen just by collecting certificates or knowing coding. You have to be a problem solver. Coding is only means to an end. Okay. So I mean that is something that the earlier you understand, the better it is. In IITs, especially the top IITs, I have seen that culture is there. It basically trickles down from their alumni. So they know they really have an understanding कि करना क्या है. What we do, जो सब कर रहे हैं वही करते हैं. We hate herd mentality, but that is exactly what we do. So the earlier you understand that, the easier it is to pick on things.
Yeah, probably just 2 lines to add to it. I mean, as for me, I see analytics as an enabler, right? So you obviously need your domain knowledge and whatever you're good at, let's say marketing, finance, or any particular domain that you're good at. And if you know analytics on top of that, you just can use analytics to improve on what you know, right? So use analytics just as an enabler. So that's how I see it, or that's how it works basically.
Yeah, somebody has
I
actually
see one
asked a question
question.
about analytics. Okay,
Yeah.
Arun, just give me a second, because we had actually floated a contest on that. See, and to add on to that, somebody also asked, you need lots and lots of data. So is it just that the big, huge companies can then, rule the roost or make money, and we are left behind? This is also something somebody has asked. Now, we are a very, very small, micro, minuscule company when you look at companies across the world. Okay. And yet, so we actually launched a challenge that if you, I mean, probably Amrit can share with you our website link. So we have posted our predictions on COVID numbers. We have posted our predictions on GDP numbers. And we did that starting March. So if even that challenge is open now, if you can find anyone, any university, any large organization, anything in the world that has made better and more consistent prediction than us, we'll give you a gift voucher worth 50,000 rupees. Till now, nobody has claimed it. So you can go to our website, see our prediction, and you can see that everything is, timeline. You can go to Twitter, our Twitter handle, you can see that it is all timeline. Every prediction that we have made. We have not gone, we have gone till, let's say, 99.95% accuracy. The lowest would probably have been 98.9, something like that. And that was for a prediction that was 60 days ahead. And GDP numbers we had predicted in March, which was to put it in plain simple terms, 1,000% off of what IMF had predicted. But over the last 8 months, IMF's numbers have come closer to us. Goldman Sachs numbers have come closer to us. So it does not matter how big you are or small you are. What matters is how good you understand the subject. That is what matters. Again, this contest is open to you. If you can find anyone in the world who has made better prediction than us, there's a 50,000 bucks gift voucher waiting for you.
Even
Yeah,
I
Amrit,
can give the
sorry,
example
Arpit,
of
you're saying
my
something?
company as well. I mean, we just started about 5-6 months back, and we are currently the biggest player in the space. So yeah, it
Correct.
doesn't matter.
And I think there are a lot many
If you
spaces. I think,
if you have a right way
sorry,
of
Arpit. Yeah, yeah, go.
collecting the right data, then you're good.
And I think just to add to that, I think there is no denying that the Googles, Amazons, and the Facebooks of the world, they have all the data because they have bots fixed everywhere. But that doesn't stop others from, working in this analytics space. And as Arpit said, right, you have niche sports analytics companies. You have niche NLP based companies. You have, I think there was a company I just read yesterday that they raised some 50 billion funding and they work on the audio transcription part. Why couldn't a Google or an Amazon do that? So having just the data in of itself, it's not enough. I think you have immense opportunity, and if you have enough talent and attitude, as Gaurav was trying to say, I think there is no stopping anyone.
I think we have virtually answered all the questions that are here.
Wait.
One of the common thread among these questions is also, are AI and ML going to replace all the jobs?
Yeah, it's
Very, very
uh,
possible. Very, very possible.
actually, as per my opinion, I think that those who really understand analytics also understand the fact that this is not going to happen anytime soon, or this is not going to happen because at the core of it all, we are basically building all these systems, right? So the way these can go wrong will probably need time, if at all they're happening. Um, but as of now, I don't see it happening anytime soon.
I think what they mean by that question is the jobs we generally see. Of course, nothing will eliminate anything in that sense. So there will be a lot of jobs which will always be there. But jobs which basically employ most of the people right now, those jobs could very well be eliminated by AI ML. And see, one of the major employment generating sector is transportation. That your drivers. So it's not just driver, there are many other people associated with it. So that is the industry that is going to take the biggest hit with your autonomous vehicles coming into play.
Yeah.
And the only reason why autonomous vehicles have not come into play is not because of technology, it's because of the legislation, the laws. Once you start tampering with it, that could be enormous unemployment, and that could turn elections results in anyone's favor or against somebody. So there are a lot of things at play as well. It's not technology.
There's actually one more unanswered question regarding neural networks, the number of hidden layers in neurons. Uh, does increasing the number of hidden layers increase accuracy of a neural network? I would say not necessarily so, because um, after running the model, or when the model is being run, each neuron takes responsibility of doing a certain task, classifying a part of the image as something or something else, right? So, and the way you understand this is only by doing, right? So, if you build a lot of neural networks, then probably you would get an understanding behind what goes on in each neuron, probably just an intuition of whether a new layer will work or whether more number of neurons in one layer will work, right? So and it depends on the use case. What works for one use case may not be true for another use case, let's say. So um, and it's a black box, like we said earlier. So unless you do, which I don't have a lot of experience building neural networks, so I'll not be in a good position to answer whether and like what will be the most important factor in determining the accuracy. But all I can say is it's just, you'll know that just by doing it, right? So the more experience you have in this field, the better you can understand what will work in what scenario. Yeah, I think we have answered all the questions.
All right. So we'll probably call it a day. Thank you, guys. Thank you for your patience. I hope you got a few things cleared up and you got a lot of things confused, because confusion is good. Confusion brings clarity. If there is no confusion, it means you're not really learning anything. So the more you learn, see that this is a curve. The more you learn, the more you get confused. The more you get confused, the more you work on clarity. And when the clarity comes, you have actually learned a lot of things. You could also go into Feynman's learning techniques. That is something very interesting. It could actually be applied to neural networks. So anyway, thank you, guys.
Yeah,
thank you, NITR Fin Club. All right. Signing out.